So let's pick up where we left off in class today. We were solving this oblique triangle and we were finding the angle C, the angle opposite the largest side, using law of cosine. And we had just calculated that that angle was 82 degrees. Once we know the measure of the largest angle, from there we can use law of sine to find either of the other missing angles. So I'm going to choose angle A. And because we now have a pair of opposite information and an opposite side, since we have three pieces of information, we can use law of sine again. So since I'm solving for angle A, I will find the sine of A and divide that by the side opposite angle A, which is 7. Because sine A is top left, then I'm forced to use sine of an angle in the top right. And in this case, I'll use 82 degrees because I've solved for that angle, and then the side opposite 82 degrees is 8. So let's isolate sine A by multiplying both sides by 7. And then let's calculate this. So 7 times the sine of 82 degrees divided by 8 gives me a value of 0.8665. Now remember, we have not yet solved for A. That 0.8665 is the sine of angle A. So if you had a right triangle, this would be like opposite over hypotenuse. So remember, to actually calculate the angle, we have to use the inverse sine function. So let's do that now. And that gives me an angle of 60 degrees. And so finally, we can calculate angle B by adding angles C and A together. 82 plus 60 is 142, so that leaves me with 38 degrees for angle B. Let's make sure that's right. And it is. All right, so ladies, if you'll turn to goal 3 in your notes, please. We are going to find the area of an oblique triangle. And I see these two practice problems. You can skip those. I'll probably have you do those in class tomorrow just to check to make sure everybody understands. So if you'll go on down to goal 3, find the area of an oblique triangle. Now, I'm quite certain that you know how to find the area of a right triangle using area equals 1/2 base times height. And you hopefully recall from your geometry course that base and height always meet at a right angle. So I want to pose the question, the area of an oblique triangle can or cannot be found using area equals 1/2 base times height. Hopefully you circled cannot. It cannot be found because, again, base and height meet at a right angle, and an oblique triangle does not have a right angle. So I'm going to introduce you to two formulas that allow you to calculate the area of an oblique triangle. Let's look at the first one. The first is to find the area of an SAS triangle. Remember, that's the type of triangle when we know two angles and an included side. So let's draw a triangle and look at this. All right, so here's a triangle. If I have an SAS form of a triangle, then I know two sides, and I'm just highlighting. So let's say you knew 2 yellow sides. Then if you are going to use SAS, then you are forced or if you have SAS, then that means you know this angle that I've highlighted in green. We have a side, and the angle that those two sides create. If I mark an angle here in blue, this does not represent SAS. This would represent an angle and two sides that do not create the angle. So make sure you understand that SAS triangle is two sides and the angle between those sides. When you have this relationship between two angles, between two sides and an angle, then you can use this formula to find the area. Now I know you see that I have three separate formulas here, but it's not required for you to memorize these three formulas. What I want you to memorize is the relationship between the variables in the formulas. So let's talk about those relationships briefly. I'm going to label this triangle angle A, angle B, angle C. If this is angle A, then the side opposite is side A. If this is angle B, the side opposite is side B. And if this is angle C, the side opposite is angle C. What I want you to recognize is if you're going to use half BC sine A or half AB sine C or half AC sine of B in order to find the area, it's all in the relationship. Let's look at the first equation. 1/2 side B, side C, and angle A. Well, what do you notice? B and C create angle A. If you are going to use half AB times sine of C, here's side A, side B, and the sine of the angle that those two sides create. Let's look at the third equation, the third formula, and see if it has the same relationship. Half AC sine of B. So half of side A times side C times the angle that those two sides create. So I want you to hopefully understand that when you're using half BC sine A, really what you're using is 1/2 two sides and the angle between them. So this formula can be thought of as area equals 1/2 times two sides and the angle between them. All right, so that's how we would find the area of an oblique triangle where we only know two sides and the angle between them. Let's look, how do we find the area of a triangle that is not a right triangle, but we know all three sides? There's something called Huron's formula. Here's the formula for that. It says the area is equal to the square root of S times S minus, let's change that to an A, that's a typo. So we fixed that typo. So the square root of S times S minus A times S minus B times S minus C. And I need to define S for you. S is 1/2 the perimeter of the triangle. So in other words, remember to calculate perimeter, you add the three sides of the triangle, and once you have that sum, you find half of that to calculate S. All right, so let's put these two formulas for area to work and see what we can come up with. A, find the area of the triangle with side A, side B, and side C. And I would like you to take a moment and draw a triangle and label the sides. All right, so we see that we just know the sides of the oblique triangle. Let's calculate S first, since we need that for Huron's formula. We know that S is half the perimeter, so that's 1/2 times 6 plus 16 plus 18, so half of 40, and S is 20. So when we're finding the area using Huron's formula, and again we're using that because we know the three sides only, we begin with S, or 20, times S minus A, so S minus 6, or 20 minus 6 is 14, times S minus B, or 20 minus 16 is 4, times S minus C, 20 minus 18, which is 2. So take a moment and find that area on your calculator, please. And that area is 43.3 units squared. Oh, they gave us meters, so we'll say meters squared. In example B, we're asked to find the area of a triangle having two sides of lengths 8 and 12 meters and an included angle of 135. So let's draw a triangle and label the sides. This helps you to see what you're given. Notice that it didn't tell us, it did not specify which side, it just said we have two sides of 8 meters and 12 meters and having an included angle of 135 degrees. Now remember, this is not drawn to scale, but it gives us a picture of the information we have, and we have two sides and the included angle. So that tells me to use the half two sides times the sine of the included angle. So the area is 1/2 times the product of the sides times the sine of 135 degrees. So we've got 48 times the sine of 135. We know the sine of 135 is the square root of 2 over 2. So our area is going to be 24 on the square root of 2. And let's calculate that to the tenths place. So 24 on the square root of 2. And we have an area of 33.9 meters squared. Now, if you want to double check that by typing the entire equation into your calculator, I'm happy to do that. So let's check that. 0.5 times 8 times 12 times the sine of 135 degrees. And you double check 0.5 times 8 times 12, sine of 135. Yes, and we still get 33.9, or approximately 34 for our area. Thank you, ladies, and please make sure that you complete the practice assignments this evening.